could they be? One method of measuring just how much is provided by the Kardashev scale.
The Kardashev scale classifies potential alien civilizations into 3 types based on the amount of energy that they're able to harness from their local environment. A Type 1 civilization can harness the energy of only its home planet. A Type 2 could hypothetically harness the energy of its own solar system. And a Type 3 could harness the energy potentially of an entire galaxy.
If you're wondering where we fit on that scale, prepare for some bad news.
We're somewhere between a 0 and a 1. We can't use all of Earth's resources, so we're at about a 0.7.
An advanced species reaching Kardashev level 2 or even 3 could create highly advanced structures that can harness the power of a star.
If you get to be an advanced enough civilization, eventually, if your energy demands are so huge, you might build solar panels that you have enveloped your star. This was first thought of by Freeman Dyson, and so we call these Dyson spheres.
If such epic engineering occurs in other star systems, or even other galaxies, could we pick up some evidence and then make first contact?
The thing about a Dyson sphere is that you've completely blocked all the light coming out from a star, except for the infrared, because these panels are absorbing that sunlight and warming up. When you warm up an object, it gives off what's called thermal infrared light. You can scan the skies looking for that signature to see if there are any Dyson spheres out there.
2015. NASA's Wide Field Infrared Survey Explorer scanned 100,000 nearby galaxies to locate advanced Kardashev civilizations by observing infrared light leaking away from Dyson spheres. They detected nothing.
No such galaxy was found, so they didn't find any infrared smoking gun.
Given our universe is so old, surely other civilizations should have had time to evolve. If so, maybe we've simply missed them.
It's entirely possible that civilizations arose, tried to communicate with the galaxy around them, and the problem was they were asking too early for us. They're trying to knock on our door, but our house wasn't built yet.
Earth has been around for under 1/3 of the universe's 13.8 billion year lifespan. The human race, just 300,000 years. A relatively tiny window of opportunity to make first contact.
We've been looking at the sky for tens of years, something like that. What is the likelihood that at that exact moment, someone is going to be beaming a signal toward us?
It's blocking the only way to the target.
Perhaps the universe prevents intelligent civilizations from surviving for very long, making our chances for first contact even more unlikely.
Maybe there is something out there that is filtering us from seeing them. We actually call this the Great Filter. Maybe there is something that says, yeah, you're not getting past here.
Rocky planets like ours are ideal for hosting life, but they're fragile. And this fragility means the universe could filter out intelligent life quickly.
We've discovered very violent star explosions like gamma ray bursts. These are powerful enough they may sterilize planets even across an entire galaxy.
And even if intelligent species survive natural phenomenon, they may still be filtered out by hitting the self-destruct button.
As we can tell from our own experience, the moment that we started developing technology, we also developed the means for our own destruction by changing the climate on our planet, by developing weapons of mass destruction. And so it's quite possible that civilizations that are advanced enough are short-lived. And if they are short-lived, that would explain why at this point in time there are very few of them that might be around to communicate with us.
Finding the relics of an extinct alien civilization could be the ultimate cosmic warning for the human race.
If we were to find a civilization out there that may have destroyed themselves by pollution or conflict, it would be almost like staring into a mirror, and it would be a very grim foreshadowing and maybe a lessons learned for us humans here on Earth.
We can only hope that some advanced alien species escaped the universe's deadly filter. But even if ET still exists out there, the odds are still stacked against first contact.
Something else. Drones of some sort. Mindless and beholden.
One other way that we've got this alien contact story a bit wrong is just down to the laws of physics.
Every day, the physics of the cosmos makes our chances of contact worse, because our universe is expanding, and it's expanding fast.
Like me require a great deal of logistics in order to get to a new star system. Because you don't even have a nexus.
February 2018. Astrophysicists at the University of Oklahoma find a potential series of rogue planets 3.8 billion light years away.
This time, we'll have additional forces. This will be a good
Ranging between the size of our moon and Jupiter, these would be the first alien worlds ever discovered outside our galaxy.
Destroyed. You're doing well. Soon you'll see the main force
And maybe
Guardians.
the first of many.
AI designed these Guardians.
Our galaxy alone has trillions of planets. The observable universe has trillions of galaxies. It's estimated about 2 trillion. So trillions of trillions? Come on.
So the Guardians are.
But finding exoplanets is no guarantee of finding alien life. And when it comes to contacting extraterrestrials, our efforts have met with silence.
Our search for life has come up empty. Do we need to change our tactics? Are we doing something wrong?
Here are a couple of wandering Guardian constructs.
I think it's going to be very, very hard to find extraterrestrial intelligence the way that we're looking for it. We would have to get really, really lucky. But I don't think we're going to get lucky. I think that if we want to know what is life out there in the cosmos, we have to go visit it.
We find the microcosmos in every feature of Earth. But where did this strange kingdom of the very small come from? Some of its members are so weird, they look like aliens. Could they have come from space?
There's this idea that microbes could have hitched a ride on a chunk of an asteroid that would fall to Earth.
They could form on a different planet, something hits that planet, the rock that they're sitting on gets lifted, and then hits the Earth as a meteorite.
The idea of hitchhiking bugs sounds a bit wild. But we have found chunks of Mars on Earth. Perhaps these space rocks brought life.
It's not completely ridiculous. We know that rocks, for example, could come from Mars and land on Earth. A giant asteroid impact on Mars could blow shrapnel into space that could land on Earth.
To learn how, we must return to the early solar system, 4.5 billion years ago. Many infant planets orbit a new star, our sun. This infant solar system is chaotic. Collisions between planets are inevitable.
The early solar system was like a pinball machine. Stuff was hitting, knocking stuff off, that would land somewhere, knock stuff off.
The young Mars is in the line of fire. It already has primitive oceans, and perhaps primitive life. A huge space rock smashes into the surface. We call the event the Borealis Impact. It blows quadrillion tons of rock into space.
It's not crazy to think that one of these chunks of rock traveling through our solar system has some hitchhikers on board.
If there's some microbe riding on an asteroid that got blasted off of Mars, kind of feel sorry for it, right? It's just living there on Mars, doing whatever little Martian microbes do, and then a giant impact ejects this thing into space.
We are concerned. In order to get from one planet to another, cell would have to run a gauntlet. It's almost like winning a survival game show. You've got to survive being blasted off your home world. You've then got to survive the interplanetary journey inside a small lump of rock, being exposed to the vacuum of outer space, to cosmic rays, to UV. radiation, being dried out and frozen.
So the idea of moving life around the solar system or around the galaxy on asteroids poses a lot of different challenges.
Events like the Borealis impact ejected so much rock from Mars, there were lots of opportunities for hitchhiking bugs to run the gauntlet of space. But could they survive the journey?
That isn't the only way.
To find out, astronauts on the International Space Station grew simple bacteria outside in space.
Human minds right now. How's that working out?
After a year of being in open space,
limited by their biology.
Miraculously, some of these microbes survived. It's incredible. These microbes just could not be killed, even though they were in the worst possible environment for life.
The mission therefore shows us that life can survive the environment and outer space. Life can be transferred between planets. Maybe life did get started on Mars, on our next door neighbor planet, and then was transferred here inside a meteorite. Maybe we are immigrants from Mars.
Hitchhiking bugs may have arrived on Earth and kickstarted the microcosmos. But now, recent studies of meteorites suggest that even if living microbes didn't make the journey, the building blocks that made them did. In November 2019, an international research team found an organic molecule called ribose in meteorites that had crashed on Earth.
Ribose is a sugar. It's a simple sugar, but it is a sugar that is absolutely crucial to all life on Earth. Ribose is the sugar that makes up RNA. And RNA sits right in the linchpin of every cell.
RNA is a simple form of genetic material that controls cellular function. It's found in most primitive creatures.
Finding ribose on a meteorite is so important for us to understand the origins of the microcosmos, because these are the building blocks. These are the things that it needs to get started. So understanding where these building blocks come from allows us to understand how the microcosmos might have evolved and started.
The Rosetta mission found another building block for life out in space, a form of phosphorus on the comet 67P.
This was astounding. Comet 67P was formed at the birth of the solar system 4.67 billion years ago, and it hasn't changed since then. It's a time capsule from the birth of the sun and the planets.
And it's been in the deep freeze ever since. So these forms of phosphorus that we found on Comet 67P tell us what was available at the time the Earth was forming, and then when life was getting started on primordial Earth.
The early solar system contained many chemicals needed for life.
It's an important discovery because it means that these compounds were around when the solar system was forming. So they would have been readily available for life to tap into and use to start forming cellular structure.
These discoveries not only show that essential chemicals came to Earth, but that they exist throughout the solar system.
We tend to think of the microcosmos as only existing on Earth in the sense that only Earth has these building blocks, but now these new observations suggest that the microcosmos, at least the building blocks for one, could exist beyond Earth and throughout the solar system.
Comets and asteroids may have brought chemicals to kickstart the microcosmos. Now, explosive new research suggests that space rocks hitting Earth did even more. Could the violent impacts themselves have helped life get started? We've discovered some extraordinary exoplanets. Super-hot worlds with molten iron rain. Super-puff planets, so fragile they might blow away. Exoplanets that defy physics. But stranger still is the case of the disappearing planet. Over a decade ago, the Hubble telescope spotted a planet orbiting Fomalhaut. one of the brightest stars in the night sky.
Fomalhaut is a very nearby, very young star, and the images of this system are incredible because what you see is the central star surrounded by a bright ring. It looks just like the Eye of Sauron.
Your economy is a streaming economy.
We observed the new planet called Fomalhaut B for 6 years. Then, something surprising happened.
All of a sudden, it just wasn't there anymore. Where did this planet go?
For it to suddenly be gone, it was amazing. It was astounding. It was terrifying.
If Fomalhaut B can suddenly vanish, what could that mean for other planets? And us?
We live on a planet, so we have a vested interest in understanding how planets could disappear if that's a phenomenon that exists.
These indestructible buildings are extremely important.
October 2019. Astronomers investigate the idea of a vanishing planet by looking at BD plus 20307, a star system straight out of the movies.
Just like that iconic image from Star Wars, from Tatooine, where you look up and there's 2 stars in the sky. It's actually not that crazy.
Out there in the wild, wild west of the universe, you have lots of different kinds of star systems. In fact, it's more common to have pairs of stars orbiting each other than have stars by themselves.
If 2 star systems are the norm, what makes BD plus 20307 different? The 2 stars lie within a bright disk of gas and dust, like Fomalhaut. But Fomalhaut is a young system, less than 500 million years old. BD plus 20307 is 1 billion years old. And that's weird, because the material in the disk is so old, it should have formed new planets long ago. So what's going on?
Rings of dust are a characteristic of young planetary systems. What does it mean when we see a disk of material surrounding an older star, a star over 1 billion years old? Well, one thing could be the collisions of planets. We think that in this system, planets collided, and that formed the disk that we see.
When planets collide, they don't just spew out masses of material. The violence of the event shakes up the whole planetary neighborhood.
Planetary objects come in with such energy and such speed that essentially they are vaporizing each other.
Observing a planet essentially being destroyed tells us something about what might happen in our own solar system. Our planets feel very stable in their orbits, but we don't realize that in the future, those orbits might be very different than they are today.
Early in its existence, our solar system was a demolition derby with many, many collisions. It's how rocky planets like ours form.
Back then, there were more than 8 or 9 planets in our solar system. There were hundreds, and planets were running into each other and interacting with each other all the time.
Eventually, the planets we see today formed, and our solar system settled into a nice, regular arrangement. Finding strange systems like BD plus 20307 makes us question that narrative.
One of the really valuable lessons that astronomers have learned from studying planets around other stars is that it appears very clear now that planets don't necessarily stay where they are in a solar system.
Over time, the orbits of planets in our solar system slowly shift. The repercussions of these orbital fluctuations could shatter our cosmic neighborhood. The odds are slim, but billions of years from now, Mercury could be pulled out of its orbit by gravitational interactions with Jupiter. This action would set Mercury on a fateful course.
One potential future that our solar system may have is actually that Mercury could collide with Earth, which sounds crazy, but would also be a real bummer.
So what we see in BD plus 20307 is theoretically possible in our own solar system.
It's actually been a bit of a wake-up call. It's a transformation in our understanding of how our solar system works.
Studying other systems shows us just how vulnerable planets can be.